Assalamualaikum warahmatullahi wabarakatuh. Today we will present our group assignment topic, area between two curves. First of all, let me introduce our Metaleads members. It is consist of me, my name is Nur Shazani binti Rusti, and I am from CS 110-2B.
My name is Nur Anima binti Hassan. I'm from RCDCS 110-2B.
My name is Nur Shazana binti Abdul Malik. My matric number is 2023-841054. I'm from CS 110-2B.
My name is Nur Nazir Hana binti Hussein. My matric number is 2023-613364, and I'm from CS 110.
Now, I'm going to talk about introduction. What is integral? Integral in calculus are mathematical tools used to find the accumulated quantity over something over a range. They come in two main types, definite and indefinite. A definite integral calculates the asset total of a function over a specified interval by summing up infinitely small part of the function. It's like adding up countless tiny slices to get a precise sum. An indefinite integral, on the other hand, finds a family of functions that, when differentiated, yield the original function being integrated. It essentially reverses the differentiation process, allowing us to find functions that could have led to the given function.
Next, applications of integrations. So, for our group assignment, we will explain about area between two curves. Step to find areas. Step 1. Look at the function given. If it is y in terms of x, then the graph is parallel with x-axis. If it is x in terms of y, then the graph is parallel with y-axis. Step 2. If graph is parallel with x-axis, look at the graph start with the x-axis to above to recognize the upper and lower function. Step 3. Repeat step 2 but for y-axis if your graph is parallel with y-axis. Then step 4. Implement the function into formula. Step 5. Simplify the function. And last step, you must integrate your function and you will find your areas.
So, this is the example of the graph. On the left-hand side is a formula for graph that parallel with x-axis, while for the right-hand side is the formula for graph that parallel with y-axis. For formula of finding area is a to b upper function minus lower function dx. For the graph that parallel with x-axis, you should look from x-axis to above. For example, in this graph, your y equals to gx is your upper function, while the lower function is y equals to fx. And next, for the graph parallel with y-axis, you should look from y-axis to the right. For the example, x equals to gy is your upper function, while x equals to fy is your lower function.
Now, I'm going to explain about problem statement and solving. For question number 1 is, the diagram below shows the region R enclosed by the curve y equals 1 over x squared. The line y equals 8 and y-axis. For A, find the coordinate of P. Y equals to A as a equation number 1. Y equals to 1 over 2x squared is equation for number 2. Use substitution method. Sub 1 into 2 and 8 equal to 1 over 2x squared. And then the equation will become like 16 equal x squared. And then x equal to positive negative form. Therefore, P is a equal to 4 and y equal to 8. Use the positive value, which is positive form, because P was located at positive areas.
Question B requires us to find the area of region R. First, we must know the lower and upper function. From diagram and function given, we can know that our graph is parallel to x-axis. So, from the diagram given, our upper function is y equals to 8, while our lower function is y equals to 1 over 2 x squared. How to recognize it? Like I said before, look at the graph, start with the x-axis to above. Then, in questions A, we already find coordinates P. Use x from coordinates P and x equals to 0 for our definite integrals value. It is because our shadow region limit that start with 0 and end at coordinate P. Next step, enter all of our information into our formula. Our formula is A to B top minus with bottom dx. Then implement all of our information into the formula 0 to 4, 8 minus 1 over 2x squared dx. Then integrate the function 8x minus 1 over 2x cubed over 3. We separate 1 over 2 and x squared because 1 over 2 is constant. Then we must simplify our function. Multiply 1 over 2 with 1 over 3 equals to x cubed over 6. Next, implement the limit value into our equation. So 8 multiply with 4 minus 4 cubed over 6 minus 0. Why 0? Because 8 multiply with 0 minus 0 cubed over 6 equals to 0. And finally, we got the shadow region area. Our area is 64 over 3 units square.
For question 2a, the diagram below shows that the shaded region are bounded by the parabola y square equals to 5 minus x and the line x equals to 1. And the solution is, from the equation, make x equal to 1 into first equation and y square equals to 5 minus x into second equation. Then substitute equation 1 into 2. After the calculation, we got y equals to positive 2 and y equals to negative 2. Then substitute y value into second equation. After the calculation, we finally got the coordinate of P, which is 1, 2, and the coordinate of Q, which is 1, negative 2.
Next is question 2b. We need to determine the area of R. For the formula of area, we need to know the right function and left function, which is right function will minus the left function. We know that the equation for right function is the straight line P and Q, which is x equal to 1, and the equation for left function is y square equal to 5 minus x, and we can change the equation into x equal to 5 minus y squared. And then we use the equation into the formula, which is it will make 5 minus y squared equal minus 1 dy. For the point B and A, we can take the point from P and point from Q, which is P we can take for y-axis, which is 2, and Q for y-axis is negative 2. And then we can calculate the equation 5 minus, when we remove the brackets, we will get 5 minus y squared and minus 1. Then integrals 2 minus 2, it will become negative y plus 4, which is 5 already minus with 1. And then we can integrate the equation. It will become a negative y to the power of 3 over 3 plus 4y. And then we can substitute the points negative 2 over 3 to the power of 3 over 3 plus 5 times 2 minus negative 2 to the power of 3 over 3 and plus 4 times of negative 2. The answer for the first bracket is 16 over 3 and the answer for the second bracket is negative 16 over 3. When we minus the equation, the final answer will become 32 per 3 over 3 unit square. That's all for this question. The last one is conclusion. The area between two curves is a fundamental concept in calculus, typically formed by computing definite integrals. It represents the region enclosed by the graph of two functions over a specific interval. To find this area, one calculates the definite integrals of the absolute difference between the upper and lower function with respect to the variable of integration. This method ensures that the area is positive and correctly reflects the enclosed region. And this is our references.
Thank you.